Hi everyone, welcome back to SolidWorks course, and in this class we'll be learning more about SolidWorks and its different features. So as we saw in our last class, what we did is that we learned how to model this part from its 2D drawing. And as we saw in the last class, we started with a rectangular piece of material and then we cut the different features of the part until we reached the final part. However, when we are working with different parts and model and designing different parts for various applications, we will most of the time have parts that will not make so much sense to start with a rectangular piece of a material, since they will have some other symmetries that we can exploit, such as the part that we'll be working with today, which will teach us various different new features in SolidWorks. So we can see our part here in the isometric view. And as we can see here, it has a circular symmetry. We can see that it has a lot of circles and we can exploit this feature so that we can model this part as efficiently as possible when compared with starting with a rectangular piece of a material, since it will not make much sense to start with a rectangular prism material and then cut it to have this shape, even though it might be possible. So in this part, we have its 2D drawings in here. We can see that we have here the top view of the part, and we can see here this section view. And so what this does is that we can see those lines that explain the plane that will be used for the section view. You can think of a section view simply as if we have a knife and we use it to cut the part. So here we have in SolidWorks a feature to show the section view. So this is what we'll be seeing. So what's happening is that this plane is cutting our part from the top in the middle, and thus what we'll be having is something like this. We will have some parts that are shaded in this or hatched in the section view, which are the parts that are in direct contact with the cutting plane, or if you want to think of it as a knife. So we can see here, for example, the hole is not touching the plane, and so there's nothing in here, but the various different areas of the part are colored here in blue, and here they are hatched in a 2D drawing. And so we can see this section view, which helps us to explain the part in a different way when compared to a right view, for example, as we did in the first part. And so what we'll be doing is that in this part, in this class, we'll be exploiting, again, as I said, the circular symmetry. And so what we'll do is instead of modeling all of this part, what we could do is we could simply sketch only this top half of it, and then we could revolve it. So if you see here in the isometric view, this is what we'll be doing. And then what we'll do is that we'll use SolidWorks Revolve feature to simply revolve this sketch 360 degrees to create our part. And so let's get back to SolidWorks. So here we start with a blank new part, and what will go as we start with every part with the sketch. Here we could start with the right plane. And so the first thing, as we said, our plan is that we will sketch this top half, then we will revolve it. After that, we'll be doing the various different features like this holes, those 12 holes, and those rectangular shapes. So with our plan in head, we can start with our part. So first of all, we will use the line so that we can draw this what is it, contour in general, roughly, and then we could add the different dimensions. So we have something that is like this. And then here we have this circular part. To draw this, we could simply go to this where we'll have a 3-point arc, and then we could put 2 points, and then we could define the radius of the arc. For now, anything will work, since later we will define its dimension. And then we could continue. Or as a shortcut, what you could do is that when you are in the line command and when you are drawing, you will go with a line. But if you go back to the point of the previous line, you will start drawing an arc. So you could use this to increase the speed of sketching different features instead of changing to a different command, the 3-point arc, and then going back to the line. So continuing with this feature, we could go like this. And so with this, we have a very general rough sketch of what this is looking with the important features. What we could do now is that we could simply put the various dimensions in this part. So first of all, we'll be using this section view of the part to get the dimensions related to its thickness. So we can see here we have a 45. So if we go to smart dimension, we have this. We have this part being 45. And an important thing is that to mention is that here we are working with millimeters, as we can see here in the title block of the 2D drawing. So we have here the 45 millimeters. Then we have this area, which is the difference in the height between this area and this, which is simply 10. We could also put this in here as 10. We are done with those 2 dimensions. We can go to this one, which states the height of this bottom part, which is also 10. Finally, we have this 45, which describes the height of this part. And if we click on those lines, we could have simply define this as 45. And as you can see, every time you are dimensioning this part, the lines change from being blue to being black. With blue being like they are not defined, we can move them, but the black, they are constrained. And so this is what we want. We want all of the lines in the sketch to be black. So we could simply take this a bit closer. And then what we could do is that from here, we can define the radius of this circle, which simply, again, with smart dimension, radius, and we could define this as 15. After that, with this, we have all of those dimensions used. So we could go to the top view or front view. You could also call it as a front view in this case of the part to know those dimensions. So in here, what we could do is that we could dimension this section of the part using the information of the diameter of the part. So if we see here, we have 360 as the diameter. This symbol indicates a diameter, where an R indicates the radius. So we have here the diameter, and so all of this is 360, and so this would be half of it. However, instead of calculating this for every part, you could simplify it by using a center line. So if we have here, we have this is the normal line that we are using, but there's also what we call construction geometry, which helps us to create our part, but they are not part of the part that we are modeling. So if, for example, we draw this section, this center line, we can see that it is a dashed line instead of a solid line. The difference is that when, for example, if we want, for example, to extrude our part as we did in the last class, this will not be part of what we will be extruding, because this will be used just to help us in our sketching. So with this, we can go with a smart dimension. Again, as we said, this is 360 over 2. You could type it as 360 divided by 2, which SolidWorks will calculate immediately. Or what you could do is that you could simply take this dimension, and SolidWorks knows that by doing with this center line, SolidWorks assumes that you will be later revolving it. So if you go below this line, what happens is that SolidWorks will somehow reflect this part, so that this will be the whole diameter, which we could simply directly write as 360 instead of dividing it. So this will be 360. And then we could simply clean this part a little bit. After that, we could continue. So we have here this part, the 240, which explains this area. You could also check it by simply drawing a horizontal line to see that those both features are aligning with each other. So we could simply go and dimension this as being again 240 as the whole diameter, or you could divide it by half and dimension it just from this area. So we have those features done, those dimensions are used. Then we will need to also know the diameter of this part, which can be taken from here. So we have this line that's explaining it as 100 diameter. So smart dimension, we have this as 100. So here we have everything being black except this small line at the back. So this is what we have. But if we, for example, see our part from this area, from this view, what we'll see is that this edge is hidden. Even in this isometric view, you cannot see this part. And so what will happen is that in our front view or top view, this edge will be shown as a hidden feature with a dashed line instead of a solid line, which we can see in here. So this is the feature that we want. And we can see again from here that it has a diameter of 160, which we can simply put in here as 160. With this, we have all of our features. However, if you focus, if you check here, we have this circular arc. It's not similar to this. The reason is that of the constraint. What happens is that here we have the center of our circle of this arc is coincident with this line, as we can see here in this relations tab. If we click on it, we can see that this point is coincident with this one. However, what we want is that we want it to be coincident with this line. So we could simply click on this relation and press delete on the keyboard to delete it, or we could delete it from here. Selected, right click, and then delete. So now we have this, the center of the arc floating, and so we can change it to be coincident with this line. So we select it, we select the line while holding control, and then we could simply choose coincident. And so with this, we have our part fully defined since all the lines are black. And here SolidWorks also says that it is fully defined. However, if you check this, you can see that this center line is not fully defined. We can still change its dimension. However, as I said earlier, this helps us to simply define or relate the different features in our sketch. And so its dimension is not that important since it will not be used later for creating any feature. And so with this, our sketch is done. And so we'll go to our next step, which is revolving this sketch. So we could simply exit our sketch, Control 7 to go to the isometric view. And if you go to the features tab, last class we used this extruded cut. And if we choose it again, this will simply create an extrusion of our part. But what we want is that we want to revolve it so that we can create our circular part, which will be using this revolved boss base feature. So if we select the sketch, what happens is that we will be creating our part as we can see here. And so using this feature, we need two different sections. The first one is axis of revolution, which is on which axis you will try to revolve. So for the sake of an example, if we choose this, what will happen is that this sketch will be revolved around this line. However, what we want for us is that we want it to be revolved around this bottom part, which is the center of our part. So we could simply choose this line, or we could use the construction line. Both of them will work. And then we could select our contour, which is simply our sketch. And then here we can also choose how many degrees we would like to revolve our part. So if we want it to be, we don't want it to be like a full revolution, but let's say 180, this is half of the part. However, in this case, we want it to be full revolution 360, and so we could simply click on OK, and here we have our main part. So with this, we have the main features, and what is left for us is those holes and those triangles. And for that, what we'll be doing is that we'll be using a circular pattern. So since the same feature is repeated a lot of times. So here we have 12 holes, and here we have 8 triangles, as we can see here. 12 holes and 8 triangles, and this hole in the middle. So to do that, we could simply click on the face, go to the sketch tab and sketch, or when we click on it, this comes and we simply choose sketch to start sketching on that face. So we can see here that we have 12 holes that each are 20 diameters. So we can go to the circle, and then we could simply dimension this to be 20. So this hole has the dimensions needed. However, its location is not defined. So we can see this, that it has like a circular symmetry, and it has 12 equally spaced circles. So the first one, we could simply put it vertical or at the top of the origin. So to do that, we could add a relation. Selecting the origin, left click, holding Control, and then selecting the circle. Then we can see here in the left, SolidWorks assumes that we want to add a vertical relation, which is what we want in this case. And so now we can't move the hole to the right or to the left, but only up and down. And so how will we define its location? We can go back to our drawing, and we can see this circle that is with dashed lines used for us to define the location of the holes. So we can see here that using this dimension that it has a diameter of 320, and all of our holes are lying on this circle. So we could simply we could simply create a circle like this and dimension it. However, this is just used to help us in creating our part. And as I described in the last sketch, when we want something to help us, we have the construction line. There's also a construction geometry in general. So we could simply select the circle, and then we have here options for construction. If we check this box, the circle becomes a dashed line, and this becomes a construction geometry. So this no more affects any features, but we can use it to help us in drawing our sketches. So we could go to Smart Dimension and dimension it as 320. And then, as we can see here, our holes are coincident on this circle, or they are drawn on this circle. And so we could simply drag this to the circle, and we can see here the 2 yellow icons that show that we are coincident. Or with this, it becomes black. Or what we could do is that we could simply select the center of the circle, Control, while holding it, we can select our construction circle, and then we could add the relation coincident, which again fully defines the sketch. Now, instead of drawing the other 11 circles and trying to calculate where the location of every circle is, we could simply use a feature of SolidWorks, which is under the linear sketch pattern. So if we select the linear sketch pattern, and it will have a different options. The first one is the direction, at which you want to repeat your pattern or sketch, and the entities to pattern, or like the drawings you want to repeat. So if you select our circle, we could select here the spacing and how many parts, how many times you want to repeat it. However, there's a problem. This feature gives us only pattern that is in a straight line. That's why it's called a linear sketch pattern. What we want is a circular sketch pattern. And so we could cancel this one. And if we click here on the drop down icons, we can see here circular sketch pattern. And here this will ask us for two different options. The first one is the direction at which we will be creating our pattern. And so for this, we could select any of those circular faces. For this, let's, for example, take this one. And then here, we could select the entities to pattern. Here, for some reason, maybe because before we chose this command, we were already selecting this circle for construction. And so SolidWorks assumed that this is what we want to repeat. So we could simply right click and clear selections and then reselect what we want, which is this circle. And as you can see here in this preview, we have 4 circles. However, we want 12. So we could simply, in these options, we could simply change the number of the repetitions of the entities, the number of entities we want to repeat. And so we could simply go and increase it to 12. So we have here the full 12 circles. There's also an extra option here of instances to skip. So let's say if you have a part that has something similar to this, but let's say there are some circles here that are not in the part. You could simply select them and those will not be created, but you will still have the circular symmetry. So, but in this part, we want all of them, and so we will not have any instances to skip. And so here we can simply click OK, and we have all of the holes. However, you can see here that the sketches are blue, which means they are underdefined. To be honest, I'm not sure why SolidWorks does this. You could simply just take one of them, move it a little bit, and then it will be fully defined. SolidWorks, for some reason, does not automatically defines them, but if you just move them a little bit, SolidWorks will define them as a circular patterns features. So with this, we have all of our circles, and we can see here, if we see the section view, we can see here that it's cutting the hole. We can see that the hole goes through the part. So we could simply go exit sketch, features, and as we did in our last class, we could use the extruded cut. And so here we have all of those circles selected, and we can take the option of through all, which will simply cut it through the whole thing. You can see here that there's a little bit extra because SolidWorks goes through everything, even this part that is not in direct contact with those holes. So you could also choose, for example, up to next, which will simply go from this face until the end of this face or any other, or the first face that's coming to that feature. So through all, and we could click OK. So with this, we have our features done. And so now we will do the same thing for this triangular shapes. However, this circular pattern can be done in 2 ways. In the sketch mode, as we did with those circular holes, or in this 3D modeling view or mode. So this is what we'll be doing for the triangles. Both of them can be done, and which one to use is up to you. So here we'll be using both of them to show how both of the features are created. So first of all, we need to create our triangle that will be repeating. So if we click on this face, sketch, we could go to those sketch options and we could select polygon. And from here, we could select the number of the sides of the polygon. So here, if for example, you select 6, we have here a hexagon. However, what we want is a triangle. So we go polygon, we want 3-sided. And then here, we can see that it is defined by a circle that is inside this triangle, which is inscribed circle. And so we could use it, or if there's another option that may be used for any other part of circumscribed circle, which simply draws the circle outside of the triangle or the polygon we are drawing. So if we can change the number of the sides, we want inscribed, we want a triangle, so 3 sides, and we could simply click OK. And so now we can define our triangle. So first of all, we can start with this triangle and then circular pattern it. So we can see here that our circle is a 30 diameter circle. So we could smart dimension this to 30, enter. And then since we want to create this triangle, we want the bottom side to be horizontal. So we could simply select any of the sides, for example, this side, and we could add a relation of horizontal. With this, the triangle is defined in terms of its size, but its location is not. So we will do a similar thing to what we did with the circle. So we want it to be vertical to the origin, so selecting both of them while holding Control and choosing the vertical add relation option. And then again, it moves only up and down. What we are left with was its height. So we could use this circle again, which is, as we saw earlier, it is a 160 diameter circle. So we could go to circle, we could draw it, we could draw our circle in this sketch, and then we can change it to be a construction circle. Since we will not use it to create a feature, we just want it to be able to define the place of this triangle that we'll be using for the feature. So it will help us in defining the place of this triangle. So smart dimension 160, as we can see here. So we can simply move this triangle so that it will coincide. And so now it is black. However, we still need to add this, the fillet of radius 5. And what fillets does is that they simply take any corner and they give it a curve. So this can be done both in the sketch mode or in the part mode, in the 3D view mode. So when we are sketching, we can choose this sketch fillet, and we could simply select, for example, this vertex or point, or we could simply select 2 lines. Both of them will give the same result. Then we could change it to 5, as it is mentioned here. And with this, we could simply go OK, and it is fully defined with the shape that we want. We can click OK to get out from the sketch fillet command, and then again to exit the sketch. So we have here our triangle. We can simply go to the features and extrude cut this hole, which we can see here. If, for example, go to the section view, we can see that this area is not shaded as this, which means that it is not cutting, it is not touching the cutting plane. And so it means that it's going through all. So we will go through all, and we can see here how it goes through the whole thing. So now, how we will create the other 7 parts? Instead of, again, doing the same thing and defining the angle orientation for this triangle, we could simply use, again, SolidWorks pattern feature. So we have here the linear pattern, which will do the same thing as we saw in the sketch. It will simply repeat it in a straight line. However, if we click on the drop-down menu, we can see other options. For example, we have here fill pattern. to show it. For example, we can select here the entities that we want. So here we have all of the other options for patterns are similar. So we will have here features that we want to pattern. So we could use this drop-down menu, which shows us all of the features. So if we hover over this, the last feature, which is what we created, we can see that it is the triangle that we created, the triangular hole. So if we left click it, it is selected. And for this specific fill pattern feature, it needs a boundary. So what you want to fill. So if you select this one, what it will do is that it will simply try to fill it as much as possible. And here we could work with the distances between the different features, and SolidWorks will try to fill it. However, again, what we want is that we want a circular pattern. And so we will choose from all of those options the circular pattern option. Again, here we want the features that we want to pattern, which is the triangular cut, and then the direction. Any circular direction in this case will work, since we want to pattern it in this circular direction. So for instance, let's choose this part. So we can see here that we want 8 parts, which is what SolidWorks has for now. If it's not, we could simply change it. We can see how it's repeated, and that's it. And as with the sketch mode, there's also possibility to skip some instances if you want. So we could simply click OK, and we have all of the 8 triangles created for us. So now the only thing left for us is this main feature, which is the hole, and we can take its features from here. We can see that it is a counter bore since it has this shape, and we see that the smaller circle is a 40 millimeters and it goes through the whole thing, and the bigger one, which is also visible here, this is the smaller circle and this is the bigger circle. It is a 70 diameter going down only 15. So we could do this by clicking here, sketch, and drawing the circles. The first one and the second one, and dimensioning both of them as 70 and 40, as we did in our first class with smart dimensions. From here, we could exit sketch, or again, as we explained in our last class, simply directly in the sketch mode, extrude cut to cut it. So for us, we want the smaller hole to be through all, and so this is not what SolidWorks selected for us, and so we could simply go to select contours and select the inside smaller circle and through all. Okay, we have our hole. Then we want again this counter bore part of it. So we could simply go under our feature. We can take the sketch and click on the eye to show it. We could select it and then extrude cut. Here we can see that this time SolidWorks shows what we want correctly as the whole thing, and then we want to go simply 15, enter, enter, and we have everything. Then we could select it, the sketch from here or from here to simply hide it. And so this is our part. So the only things left are those edges or chamfers that we want to create, which can be taken from this. Here we have the fillet feature, which simply creates a circular curves, as we can see here. But what we want is here a chamfer. So what we'll do is that we will go, we hide this, we will go to the drop-down menu and select chamfer. From here, we can select the 2 edges that we want to chamfer, as we can see here. We want it to be a 5, so we have here 5 and 45 degrees. Okay, and with this, we have our part done. The last thing left is that the material. Here we have copper, so we could simply go to the part, right click, go to material, and copper, left click. With this, we have our part done, And this is everything for this class. If you have any questions, feel free to ask. If not, this is everything for today.